Question 1.1 is unique of cracking the coding interview. And the question is to implement an algorithm to determine if a string has all unique characters. What if you cannot use any additional data structures? So the simplest way to do this would be to iterate through each of the characters of the string, mark whether you've seen this character already, and if you see a character more than once, you return false. Otherwise, if you make it to the end of the string without seeing any duplicates, you return true. So in the example here, we have the word hello. You can see that the L repeats, and therefore we need to return false, and the word world and has all unique characters, so you return true. So we're going to make some assumptions about the input string here. So we're going to assume that the values of the characters are ASCII, and therefore they can only be between 0 and 128. Therefore, if the length of the string is greater than 128, we know that at least one value must have repeated. So we can start by saying if s.length is greater than 128, we can return false. Now we need a way to store whether we've seen a character or not, and we'll do that by having a Boolean array called seen is equal to a new Boolean array of 128. And what we can do is index into the character's value in the seen array and set that to true every time we see it, and if we've seen it more than once, we're going to return false. So now we're going to iterate through the string. So for int I equals 0, I less than s.length, I plus plus. We're going to check the seen array to see if we've visited already. So if seen of s.char at I, then we've already seen this, we're going to return false. Otherwise, we're going to set that index to true. So seen of s.char at I is equal to true. Now, if we've made it to the end of this for loop, that means that we haven't seen any duplicates and we can return true. Now, we can try this by testing out with the words hello. And as you can see, the expected output is false. And if we use the word world, we get true, which is also the expected output. Now, before we continue to implement the function once again without the additional data structures, I just want to talk about the time complexity here. And because it's a for loop that's run the length of the string times, and the work done in the for loop is constant time, the time complexity is O of n, where n is the length of the string. To implement the same algorithm without using any additional data structures, our approach is going to be to sort the characters of the string, iterate through, checking if the current character is equal to the previous character. If so, return false. Otherwise, if we make it to the end of the string, we know there's no duplicates, and therefore we can return true. So I'm first going to comment out this function. I'm going to write public static boolean is unique, takes in a string s. So we're first going to convert the string to a char array so we can sort this. So we have a char array called letters is equal to s.toCharArray. We're then going to sort this array, so call arrays dot sort letters. Now that the array is sorted, we're going to iterate through. So for int I is equal to 0, I less than s letters dot length I plus plus. So we're actually going to start from the first index because we want to check the value previous. So for I equals 1, we're going to check if letters of I is equal to letters of I minus 1. This means that there's a duplicate and we're going to return false. Otherwise, if we make it to the end of the string, we're going to return true. Now, if we run this, we can see that our output true is indeed equal to the expected output. And now if we try the word hello, see that our output is false, which is indeed the expected output. Now, the time complexity of this algorithm, there are several parts to this. So first, we need to convert the string to a char array. And because there's the length of the string number of characters, this is going to take O of n time. And to sort the array, this is going to take O of n log n time. And we have this for loop, which runs the length of the string or the number of characters. And the work done here is O of 1, so this is a total of O of n. And since O of n log n is the longest running part of this algorithm, the time complexity is going to be O of n log n. Thank you for watching. If you'd like to see more, please hit the like button and subscribe.